Hello, this is Tong, a fifth-year PhD candidate from the Hong Kong University of Science and Technology. In this video, I'm going to introduce you our latest work collaborating with CMU and Virginia Tech towards an understanding of distributed asymmetric collaborative visualization on problem solving. Collaboration becomes crucial in modern data workflows by providing a scalable solution to divide and conquer increasingly intensive data problems. Moreover, many complicated data problems are intrinsically interdisciplinary, requiring people with decent expertise, possibly from different locations, to work synchronously for analysis. Therefore, many researchers have investigated different visualization tools to facilitate better collaboration with data visualization in PC environments. Recently, researchers found that large display space and body interactions and 3D rendering provided by the immersive technology could be helpful and beneficial in data exploration and collaboration. As a result, we can see that there is a growing interest in asymmetric collaboration. First, different computation devices have their own affordability that can complement others. Second, people have their own preferences, accessibility, and spatial ability in using different devices, such that many commercial tools provide access for users with different devices. However, only a handful work investigate in the asymmetric collaboration with data visualization. We lack an empirical understanding of people's asymmetric collaboration experiences of using visualization for problem solving remotely. Therefore, we want to know how distributed asymmetric environments affects performance, communication, and user experience in collaborative visualization. To answer this question, we first conducted a preliminary user study to understand how people collaborate with asymmetric devices and gather design requirements with 24 participants in groups of two. Besides the asymmetric setting, we introduced two symmetric settings, which are PC-PC and VR-VR as baselines. We implemented a shared working space in both PC and VR for the user to construct log-link diagram together from a set of documents for problem solving. While designing the PC user interfaces have been widely explored, the VR counterpart has limited design guidance. As the first step in exploring this design space, we considered designing the VR interface in WIMP style to align with the PC interfaces as closely as possible to reduce the potential communication burden between the PC and VR interfaces. The functions provided in both interfaces are identical, except the diagram in PC is in 2 dimensions and the diagram in VR is in 3 dimensions. We measure the task load completion time, accuracy, preference, social engagement to understand how people think about the asymmetric setting. In the first study, we found that the people did not prefer the asymmetric setting, although it did not affect performance and communication. From the qualitative feedback, we found that the participants appreciate sharing the data visualization and talking to each other during the asymmetric collaboration, but the interface should be optimized for both ends, especially the VR interfaces, and provide more explicit visual cues for collaboration. As a result, we improved our interfaces in the following 2 aspects. First, we optimized the features in both environments. For PC, we enable people to use their keyboards to provide custom labels for the look and links. For VR, we organize the documents from list form to the spatial form in VR, allowing them to make use of the spatial sense-making ability for problem solving. Moreover, we support embodied gestures using controllers to ease the interaction in VR. Besides, we provide a shared cursor that can be seen in both PC and VR environments. We make use of the natural neighborhood interpolation to provide a continuous moving cursor that can be shown between nodes in 2D and 3D environments. This cursor could then act as an explicit awareness cue similar to commercial applications such as Miro and Microsoft Whiteboards. We used the enhanced interfaces to conduct the second user study with another 20 participants to evaluate the performance, collaboration, and user experience again. We found that participants preferred more the asymmetric settings this time compared to the first time. Moreover, high asymmetric in the interface design still did not affect task performance and collaboration experience. Lastly, we found that the user who used PC in both conditions has lower mental demand and efforts in the asymmetric condition than the symmetric condition. Although asymmetric collaboration could help the PC users to perceive less mental load and efforts, there are some trade-offs in using asymmetric collaborative visualization. The first thing is we cannot afford high physical demand in VR than PC, such that the users in VR always perceive more physical demand than the PC users. Second, due to the asymmetric benefits from the environment, the workload would be imbalanced, which might affect collaboration quality in the long term. Lastly, the use of asymmetric collaboration depends on individuals' abilities and characteristics, which can be reflected by the half-and-half preference to symmetric and asymmetric collaboration. We cannot force others to use different devices for collaboration. To conclude, we found that high asymmetric interfaces would not affect performance and communication, given an appropriate design. Optimizing interfaces for both platforms would increase user preferences. Lastly, asymmetric setting creates imbalanced experience, which requires careful design in the future. That's the end of this presentation. You may also find our prototype as an open source project on GitHub. Thank you for listening.